All right, so today we're going to take a look at Helix Spiral, which can be utilized for springs, and you can also utilize it for fasteners like screws, whether it's mechanical screws, lag screws, machine screws, anything along those lines. But I'll show you how we can do this for like springs. And what the Helix Spiral does is it's similar to the swept pathways that we've looked at in the past. Okay. And really all you're doing is sweeping the diameter of the spring element around the core diameter of the spring. So for instance, if you take a spring and measure the major diameter of that spring, and on the top plane get that sketched. So let's say you're working on a fairly small spring here, and we find that the diameter of that spring is 0.1875. Okay, so that's the diameter of the spring element itself. If we move under the features tab and go to curves, there's this curve option, and drop that down to Helix Spiral. Helix Spiral is what is going to actually produce this helixing or spiraling pathway. All right. Now, the key with that is it is just that. It's just a pathway. So basically, you can work out of pitch and revolution. One of the easier options I tend to find is height and revolution, which allows you to measure the height of the said spring and how many revolutions it makes in that time. So if you say that like the spring is 3/4 of an inch, and in that 3/4 of an inch, it makes 10 point, well, let's just say 10 revolutions. All right. We can check that off, and that will produce this Helix Spiral pathway. Now, the key with this is it is just that. This is a sketch. It's two-dimensional geometry. Well, it's three-dimensional geometry in this case, but it doesn't have any depth or diameter to that spring. Okay. So what you would need to do then is grab a perpendicular plane like we've done in all our other swept functions, square up to that plane, so normal 2, and then I can sketch on that plane the diameter of my main spring element. So if we find that that's 0.02 and it's intersecting on a perpendicular plane like this, we can then take that and sweep it around that profile. Okay, so that's done under just features, swept boss base. That is the profile. This is the pathway. Okay, and then you can see that it will sweep that around that. And under your options for the swept function, we're going to move to the middle option, which will go both directions. So you could go bottom, top, or both directions, which when we check that off, will actually produce this spring. Does that make sense? All right. The other way we can use this is for fasteners. So for instance, if I had a, let's go on the top plane again, and I found that a bolt of some sort had a 0.25 diameter, and let's say it had a shaft length of 1 inch, and on top of that bolt we could make the hex head, and we could reference what size hex head we would need to actually have, a wrench that would fit on this. Okay, and we extrude that head up a little bit. You'll kind of see what I'm making here in a second. And a lot of times these bolts will have a chamfer around the edge so we can get our socket on them. Let's shrink this down. Right, so they'd have some sort of chamfer around them. So the socket slips on easily. All right. Down here, we could grab this circle that's already sketched or created, sketch on that face, and you're going to produce a circle the same diameter. So you could sketch that circle, or the easiest way is just convert entities, which will give us a sketch that diameter. And then once again, features, curves, helix spiral. I'm going to reverse this. So we'll reverse direction. We could work off the height and revolutions. If it goes the whole length, I remember this was a 1-inch long shank, and how many revolutions it makes, okay? The other option is you could go to your pitch and revolution if you know the pitch of the fastener, okay? So you could count your revolutions, and then from there, once again, we could sketch on a perpendicular plane what your thread actually looks like. Now, the key to threads is these are very specific dimensions. You would have to look up what the dimension between the threads would be. You'd have to look up this dimension. You'd have to look up this dimension, okay, which is the space between these two. But for now, just as a quick video of how to do this, we could take this, which is that little attached thread there, and then, as we've done in the past, sweep that as a swept boss base, profile, pathway, both directions, and end up with a fastener that has mechanical threads on it. Okay. If we needed to turn off that sketch, I could view high show and should be able to turn off my sketches. Oops, view, hide show, and lose those profiles.